Okay, so in this class, we'll be progressing ahead with our introduction to machine learning, and today we'll be looking at uh, what are the different steps to take while approaching a problem to in a machine learning perspective, and we also look at how can I evaluate for different kind of situations, what kind of different approaches I can take, and how can I evaluate whether whatever the approach I'm taking in fitting a machine learning model or approximating a real phenomena with a mathematical model, how good is it? What are the different techniques to evaluate? Okay, whether it is doing correct or not, right? So let's get started. So, so these are the different things that we'll be looking at. What is machine learning, which we have also looked at in our previous lectures also, and difference between supervised and unsupervised learning. We will see it again. And supervised learning process in detail. We'll look at what is the general process, how it goes, what are the different evaluating performances, or like how can we evaluate performance, and overfitting, of course. Uh, so we have seen machine learning is a method of data analysis that automates analytical model building, right? So we have like seen this before. So I'll just skip through these, right? We have seen its uses before: email spam filtering, fraud detection, credit scoring, lots and lots. YouTube, Facebook, all of them, Amazon, all of them are using it, correct? So what are neural networks? So they are the mathematical replica of the networks, neural networks in our brain. So they are artificially computing small computing units which solves problems for us, just like it happens in our brain. Okay, so there are mainly two types of machine learning: supervised learning and unsupervised learning. In supervised learning, we saw that we have examples and with labels, and in unsupervised learning, we have just examples, but there are no labels. Okay, so just a quick intro. Machine learning and neural networks and deep learning. So the broader term is machine learning here, and neural networks are a type of technique to make anything learn from examples. Neural networks, and deep learning is when the neural network gets more dense and deep, like it becomes bigger in size. We call it this as deep learning. So it's kind of a hierarchy or just some division. Right. So what is actually supervised learning? We have seen this example of a classroom where a teacher is giving instructions and telling students some rules. 2 plus 2 is 4. That thing is a chair. Sun rises in the east. So all these facts are being taught to childrens, which are kind of the ground truth. Okay, so the children are learning from exams. So okay, 2 plus 2 is 4. This thing is a cow, so the so that thing should also be a cow. Some they are making some kind of learning in their brain based on those information which are given by the teacher in a textbook in form of known examples. Okay, so such situations are called supervised learning situations, where we want to learn from some known examples, labeled examples. So they can be like some emails which people have previously annotated whether they are spam or legitimate emails, and based on that I build a model which is predicting any new mail whether it is spam or legitimate. What are positive and negative movie reviews, right? So we watch movies, we give reviews to the movies, and based on those uh, so based on the rating given by users, I can define a parameter where I can say, okay, more than 3 is positive review, less than 3 is negative review. Right. So okay, based on that, can I learn what kind of a movies, how a movie is going to perform on the box office based on the previous reviews, right? Or whether are you going to like this movie or not? Okay. Yeah, so we have kind of, yeah, so actually supervised learning definition, we have actually seen this in the previous class in detail. So I'll the major part of the today's session, I want to discuss this flow of the flow of process of machine learning, where like so we have already seen this in many different forms, but I want you guys to just get a hold of it, or yeah, we'll just save this picture in your brain somewhere. Right, so we have data acquisition, the very first step. So the ultimate goal with machine learning is that I will collect lots and lots of data, lots and lots of example to learn from, and I will learn that process. The process that I want to learn is going to be some way beneficial for me, right? So whether it is a movie recommender system, or whether I want to predict whether it will rain next year or not, or whether I should invest in this share in this company or in this share or not. right? So all kind of predictions I should be able to make. So I want to learn such kind of natural concepts which are not mathematically or cannot be explained, are not explained in theory, right? So if I want to capture such kind of events in a mathematical model so that I can predict what the future can be, so we use machine learning, and this is the flow how machine learning works. So it starts with data acquisition. I will acquire lots and lots of data. Then I will perform some data cleaning, because data can come in any many different forms. It may not be always as I want and can be used in mathematically, right? So I will perform data cleaning, and these are the data after data cleaning, the data that I have will be available for me to learn from, right? So I will divide those complete data into two sets mainly, which is one test set is test set, and one set is training set, right? So it's kind of, I have 100 questions for this exam prepared. So this will right, I'm just preparing question answers for an exam. So I have 100 questions. What I'll do, I'll just learn from those 80 from 80 questions, right? I'll revise as many times I want, and on those 10, on 20 questions I will check my knowledge, how many I'm getting correct or not, or which sections I'm getting wrong, or which topic should I revise, something like that. Okay, so I will divide my data into two parts. One is used for model training and building, and other data is test data, right? So I have examples for all these 100 or 100% of my data set. So I will just train on this. Okay, learn from these examples, tell me predict what kind of process is undergoing to give me that output, right? And on test data I will do model testing, right? So basically I can just test, okay, the first time you read all those questions, 80 questions once, and I asked you those 20 questions. Then you gave me kind of some 10 50% correct answers. Then I asked you to revise those 80 questions once more, and after that your performance remains maybe 50%, or it may go up by 60% or 70%, or is there any limit after three revisions your performance will nearly touch 99%, or like if anyone who reads these things three times, he will be able to answer those 20 questions 100% of the time, right? So I can judge these kind of parameters of from this data, right? And once I'm happy with the performance, once like after giving 4 or 5 tests and revisions, you are scoring like 19 questions out of 20, we are said, okay, yes, you good to go for the exam. That means our model is good enough for deployment. I can put it on our website, I can create an app out of it, I can so if I'm in a company, I can submit this to the developers so that they can make the changes in their application based on this to consume this model, right? It can be what kind of coupons, what kind of recharge discounts you can give, what kind of deals you can give to what kind of people, right? Who, what kind of based on what kind of mobiles they're using, right? How high end is that? So you can think of a lot of cases. Okay, so yeah, first we will collect data. Maybe it can be customers, it can be census data, of course. If you are if you're into tech, core tech, and if you go into a IoT, internet of things based company or a product based company, you will get things like data coming from sensor. You have to build model from for predicting any natural scientific behavior which I have not studied before, right? So if it rains, so what happens to the current flowing through the lights or something like that? You are collecting data from in the complete house. You to set, okay, I'll keep this thing AC running throughout the day, but I want to be it efficient, like it will just manage its temperature, it's already there. So all this kind of data collection I'll be doing, data acquisition. Then I'll clean and format our data using pandas, of course. So NumPy and pandas will mainly use here, data cleaning and data pre-processing part. We have seen lots of exercises over these. Then I'll divide my data into test data and training data, right? Test training data will be used for model training and building, and the test data will be used for model testing, right? So I'll just check my performance on the test data. I'll learn from the training data, right? And based on the revisions, the time, like I'm performing like I'm doing 5 trials, I'll read 80 questions 5 times, and after every one trial I'll go give the test of those 20 questions. It's like that, practice paper you are doing, but the practice paper remains same from the same question bank. So the model now finally, when we are happy, I'll deploy my model. Right. So it is just a simplified approach, but what we have just showed is a simplified approach to supervised learning. It contains an issue. Is it fair to use our single split of the data to evaluate our model performance? Yeah. So you can also ask her the same 100 questions are there. And once I see the 20 questions first for the first time, the next time I already know, like out of these 20 questions, whether I know the answer. So it can get, it's kind of a bias. It's not, right. So every single revision is having a different effect on your capacity to memorize or learn. Right. So after all, we are given the chance to update the model parameter again and again. Yeah. Right. So to avoid such any issues or any lack of learning, any loss of learning that might happen over here, we divide the data set into actually three different data sets, three different parts. So one, it's like you have 100 questions. I will give you 70 questions to learn, to 20 questions to test on, or test, or you can say validation. So we will call this set as validation set, and the final test is 10 questions, right? So it's like your final performance will be judged on the final test data set, the 10 questions, and you will be able to see those questions only once, final time, and that's it. Before that, you will have 70 questions. You learn whatever you want from 70 questions, then perform on those 20 questions validation data set, perform on those questions, update, learn whatever you missed out or whatever wrong you are doing, again you give the test. So you can do this reshuffling and relearning exercise between training and validation, but testing is only for once, and we can make it a stop there. Okay, it's fine, that is my performance. Okay, ultimately, so you have to give board exam is like the test set data set, and your pre boards are like this uh, validation set, and 70% is whatever you can prepare in your capacity for your boards exams. I think that's the best example, right? So validation data set used to determine what model hyperparameters to adjust. Now what the thing that I'm learning is in my model is that, okay, so for our example, if there are 20 questions, then the questions are from some subjects or some chapters, I can say, okay, chapter 5 I need to revise more specifically, so I can learn that, okay, more weight. So in out of those 20 questions, 10 questions are from chapter 5, so chapter 5 has more weightage, something like that. There should be some thing undergoing that. So two, when you adjust your performance of the model, the parameters you tune are called hyper parameters. These are not some parameters which I provide or I get as an I get. Input output is input, I'm just giving uh, questions, right? And output is whether they are correct or not, right? So these are the things which the model has to learn from these examples. Okay, so these are the adjustments that a model has to make in itself to understand the actual process, right? And test data is used to get the final performance metric. Okay, so like this means after we see the results on the final test set, we don't get to go back and adjust any model parameters. So final is like board exam done, how much you get is final. This final measure is what we label the true performance of the model to be. This is the performance of my model. So this is kind of, so it's because it's a machine. No, I can say, okay, you keep learning up for 2 years. No, I don't want. I will give you just 5 revisions and tell me what is your output. Otherwise I'll change the model, I'll do something else, right? So just to give it a stop, we kind of fix it at this kind of structure where after test data your performance is done, right? And but for the ease in our case, we'll be just using train and test split actually to keep the things simpler. So validation set is only used for like when you are going for actual deployment or something, and they it we will be only following train and test split, which is much simpler and easy to understand. Okay, next is overfitting and underfitting. Uh, so till now, what we have seen is that based on machine learning or from input and output examples, I want my model to learn something, what is happening. So what input is giving this output. So what is going underneath? So 2 plus 2 is giving me 4. And 3 plus 3 is giving me 6. So what is happening? If I'm giving 2, output is 4. What is going inside? What is the function effect? Okay, so now this function can do overfitting and underfitting, right? So it's basically you are designing so my model is like, let me just, okay, go to, maybe the meeting will stop, the sharing will stop, I'll share again. Yeah. Is it still sharing, right? Hello. I hope you are with me.
Yeah,
Hello.
yeah, it is still sharing, sir. Yeah,
Okay, okay, okay.
but the slides are not moving. If
Okay. Hi, Anup. Good to have you. So, yeah, so what?
yeah, I live in yeah. The reason the network is not good here at my place.
Okay.
That's the reason why I delayed a bit.
No, 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 it's fine. No issues. So, it's like something I want to learn is that if I enter two, this is my model, right? Model. I am giving it input and I am getting an output, right? So if I'm giving 2 and 2, it is giving me output 4. If I'm giving, if my input is 2 and 2, output is 4. If my input is 3, comma 3, output is 6.
Yeah, one minute, sir. I think if you're using the whiteboard,
uh, so it's
that
not
is not
shared.
visible.
Let me see.
I think the
I
screen
think
froze.
Yeah, yeah, it will be shared
you
now.
have to stop sharing and then you have to reshare again, sir, using
Okay,
Zoom.
okay. I think it should be visible now.
Yes, sir. Now it is coming.
Right. So, input 1, input 2, I have, this is my output. Okay. So basically, this is my model. I am giving it input and it is getting me some output. This is the actual condition which is happening with me. I want to find what is this M. Okay. So 2 for 2, if I enter 2 and 2, I get 4. If I enter 3 and 3, I get 6. If I enter 2 and 7, I get 9. Okay. So now after these three examples, we all can say that function is whatever I1 plus I2. Okay. This we learned from these three examples. Maybe just two examples were enough because it's a simpler thing, right? Similarly, we want our model to learn from examples, just like students learn from their books for their exam, right? So just like if a student, we call them if they do rote learning, they are just exactly learning questions and answers. So they are actually getting good marks. They are able to answer correctly the questions asked, but they are not actually making any learning out of it. All right. So just like this example, if all the examples I have given were 2 plus 2, sorry, 2 and 2, output is 4, 3 and 3, output is 6, 3 and 7, output is 10. And there is more examples like 33 comma 33 give me 66, right? So these are the questions I'm given, right? So it's very if someone is just learning the inputs and outputs, then it is very common. If I have a lot of examples, the confusing, if I am having very less confusing examples like this, then you will learn exactly what the function is there. Whether it is happening 2 plus 2, the function is here is 2. But if I have very high number of example of these, but and a person who has just done rote learning, he might get confused, right? So he will understand the function is of multiplying this by 2 or whatever something, because it is giving the same answers, right? 33, 33, 66. So he might not understand completely that the things happening over here is a addition. He might be just okay, the if I enter 2, output gives 4. If I enter 33, output gives 66, right? So if I have given only these examples in the beginning and 10 examples, then all of you would have said, okay, the function is 2 times of x or 2 times of any of the number. But I have given example like 3 comma 10, the output is 10. This thing is important to learn, that this whole function is not 2 times of x, right? So if some guy who is just rote learning question and answer, he might get 9 out of 10 correct, but if this question was asked, he will surely do wrong, right? We do because we are doing it for a model building in a computer, so we want to be very accurate, almost 100%, right? So if this was the case of just question answers, then if a machine learning model is learning this thing also 2 times x and it is scoring 80%, then I would be happy, right? But here we are dealing with very sensitive or and very important data, so we want to avoid all these things, right? So one guy who is just learning all the answers exactly is called overfitted, right? You are oversuited, you are just the teacher's favorite, you learn or mug up all the answers and get good marks, right? And underfitting is that most of us are like underfitting. So we are not we have so underfitting is uh, instead of doing the revision at least once, you just out of the 70 example, you just see the 40 examples and go for the exam directly, final board exam. It is like underfitting. So you have not learned for the examples, you have not done multiple revisions, right? So you don't know, you actually, so underfitting is a general case where my model is performing badly, it is not predicting whatever trend we wanted to predict, right? So it's underfitting. Overfitting is it's overlearned from the data, and it is now giving me, it has failed to generalize, generalize is I want a model which is simple, right? That's the so doing all machine learning and this AI and putting complex algorithm is all good, but ultimate goal is to be keeping things simple and easier to understand, right? So if a model is working fine, if any system is working fine without machine learning, then it is fine, there is no need to put machine learning in that. Okay, simplicity and ease should be the first goal. Okay. So overfitting, underfitting, I think we understood, and later on also I'll show you like theoretically through graphs also. So now, yeah, let's see overfitting, underfitting. So in overfitting, the model fits too much to the noise from the data, right? So noise from the data is as simple. If I open my windows, you will get all the noise from my surroundings, right? But that is not what you need to in this class, right? Similarly, whatever, so with data, a lot of data comes with some kind of noise, in some errors are there, it's not accurate and perfect. So often this results in low error on training but sets high error on testing validation, right? So basically, if it's too much to the noise means the child has done all the examples as it is, just memory, no brain applied. Okay, so now he will perform a very good on the test set, the test data set. Like in the in the exam, in the validation set, he will score very good. But so in training he will perform good. But when we go to testing or board exams, he will kind of fail. When I give him a new data, he might not be able to predict correctly, right? So this is suppose this is my data distribution. Any two you can take this is height and weight. Now let me write it, height, and this is weight of some students, right? Right, students. So I this is the behavior, you see, height and weight of students of some group. Maybe you can say there are students from China, right? And I want to model how, like, what is the relationship between height and weight of students or of students throughout the world. Whether there is a differentiation country wise, or some students this is the height weight ratio or whatever. So this is just two parameters which I want to study, so I can clearly see that a good model should perform like this, or this will be a good model if I want to predict this behavior in with just a simple curve, right? So I can just put this curve, or maybe like this curve, whatever. Like here I can draw a smooth curve to represent this behavior. Right, now overfitting is I am learning all the examples, right? Here you see, here my model, it is not passing through all the points, there is some error, right? The y values for x, this should be the y, my model. So the to read this graph is that for this, but all these gray points are the data that I know. For a point like this, okay, for a point like this, so suppose I want to study about this point, then for this at this given x, the y value should be this, right? This is the prediction. But when I see about this point, so my model is saying the y should be this, but the y is actually this, right? So there is a difference of this height in most of the points, but in order to generalize it is fine, right? So I'm just here and there, but my error is kind of minimum, I can see that, right? But if I learn something like this, I draw a curve which passes through all the points. I've learned every example multiple times, every answer I know, right? So this is a better, bigger, like, it is very good for a training set. But when it comes to generalizing, it will fail badly, right? So suppose there's a new point for which I want to figure out what is the prediction. So prediction says this much, right? So this height is too much, it is giving me this much of error as compared to this. this thing will never give me any absurd value. We know that the values are going to lie between somewhere here only. If this green curve is my predictor or my model, but if this is my model, like for this value or this value may get so we know that with intuition all of the values might lie somewhere like this. These can be the distribution, not these extremes that the overfitting model is learning. Okay, so it's better summarize. It is not good at summarizing or generalizing or applying the concepts actually, but he's really good at rote learning. He learned all the examples, but he's not able to perform actually in a match, right? So it's okay. So now we're going to underfitting. So model does not capture the underlying trend of the data and does not fit the data well enough. So it's like not preparing well for your exams, not even not reading the complete syllabus once, right? It's so it's you know that you're not going to perform really good, just you want to going for passing marks, right? But that thing is bad in case of a machine learning concept, because we want our model to be really good, right? So it has low variance but high bias, and underfitting is often as a result of an excessive simple model, right? So your behavior is something like predicting this trend of pandemics. Okay, so what is the trend throughout the year? Which what kind of known viruses become more active in which time and which area wise? Such kind of a complex model I want to predict. But I'm just using a simple, okay, I want to predict this all these things using straight line or a combination of straight lines, right? So the behavior can take any shape now for each, or maybe it can go down. But if I'm using a simpler model to predict my phenomenon, then I may be wrong, right? So if I expect a child to, okay, just go appear for this board exam and you are in second and third class, right? So he is not in capacity to understand or to give the answers to those complex questions. So it will be kind of a underfitting, or you have not read, you have not attended any of the classes, you don't know anything about the subject, and you are going to attend the exam, you're going to perform. So you have a very simple model of the subject in your brain. Okay, I'll just give answer whatever I understand from the question, I'll write there. So you will get there's that much of your performance. Okay, so with here's a term, just keep this in mind, variance and bias. We will look in detail maybe in the next lecture, right? So this is underfitting. So if I'm just defining this whole phenomena with this straight line, right? So what if I want to go further in this direction? So this is what height and weight, right? So okay, I can go for what height, what should be the weight, right? For this height, what should be the weight? So my model is saying this and this and this, right? So maybe it is not possible because it is more of like this only, right? Which this curve was able to perform, able to guess. But this line is like, for initially it is performing well, but when I go towards an extreme of a feature, it is going to give me lot increasingly high amount of error. It is underfitting, right? So this data was easy to visualize, but how can we see underfitting and overfitting when dealing with multi-dimensional data sets, right? So both of these representation are two-dimensional. I can just compare and see distribution of just two variables, because I am doing this on a plane. So if you do it on 3D, you may be able to see it in three dimension, visualize it and say, okay, it is far, it is near, it is different, all that. You can use your visual perception to see how data is distributed. But any actual phenomena has a lot more features, a lot more parameters on which it may depend. Okay, so suppose we are talking about recommending videos on YouTube. Okay, so what are the different types of videos that my user has watched, right? What is the time duration for which he was watching these videos? Then what are the different kind of articles he searched, right, on Google? So whether they were about making videos, or he has a YouTube channel of his own, or maybe some other information, right? So there are a lot of features that I want to in see at once, where how they affect my model or how they affect the phenomena that is happening, right? This phenomena is uh, buying and selling and getting promotions, right? Making money. So for the company, the phenomena is how can I get more customers, make more money, use uh, some mathematical concepts to make me rich, right? So let's imagine we trained a model and then measured its error over a training time. So it is like training time, the number of revisions you are doing, and this is your error. So it is like just after 5 I take your exam. 10 years I will take your 10 hours I take your exam. 20 hours, 40 hours, 50 hours, right? So after like you have given 5 6 revisions, this means 5 6 revisions. Okay, your error will going to reduce, right? Epochs means number of revisions through the whole data set after, right? So you have 80 questions to learn from, and you will get like what, uh, these many number of iteration revisions until you reach a final performance. Okay, so in actuality, if I give you 80 questions and 20 questions, like almost all of you can go 100%. So this graph will become zero at this point if the our case was just those 100 questions and you have to answer all of them. But in a real scenario, this is the trend where error will reduce with number of revisions of training time, right? So a bad model is that initially you have less error, and next you are giving a very large error, right? So it is like that kid who learned that the function was 2 into x. So he will give initially, when I'm asking 2, if I input 2 2, what is the output? What is the input of 4 4? What is the output of 5 5? He is answering all correct. When I switched 1 5 2 6 7 8 9 10 4 8, so he is all bluffing. It's a bad model, right? So basically, when thinking about overfitting and underfitting, we want to keep in mind the relationship of model performance on the training set versus the test set. I need to just keep in track this performance of my model. So my model is like a child. I want him to learn something, and I want to keep a track of his performance, right? So whether he's just rote learning, I have to keep asking him surprise questions. I need to keep giving him more books and more resources to learn from, more examples to learn, and I should be having a big data set to test data set to test him, right? So I need to keep building both of these. So I need to keep these model parameters and the training set of performance of model parameters on test and validation set, based on whatever he's learning, how he's performing on that validation set, and how it is performing in the final exam, because our final exam is what that matters, right? So it's if we of course, once you give the board exam, it's done. So similarly here also, let's imagine we split it into training and test set, right? So first we see the performance on training set. So we have divided our data training set. So basically from those 80 examples, you are learning from 80 examples, and I'm just training, I'm finding your error in the training data set only, right? It's training set, seeing the performance on training set. Then I am giving my performance, I am giving you test set, and based on that I am asking you questions. So my way of learning is that I'll revise the 80 questions, I'll take a test out of that 80 questions only. That will be my training loss, that red line, right? Then I will just take those 20 questions and test my performance on that after or for each revision, right? That will be my test set. Of course, will be going to be more, assuming that there is always something that we did not learn. It may happen that you go, I gave you once to read, you answer all the corrections, so your graph will be same, right? So your error will be what? Your graph will be like this line only, because your error is zero in the very first revision is zero. So your line will look like some this thing only. This will be your graph. It is zero. You started from here. There is no error. Nothing in y-axis. This x-axis does not have nothing. Just one. This will be your data. This will be your graph for your specific case. But in general, this should be the graph, right? Which is following our trend. It is decreasing. We are also decreasing. Initially, it was zero also. Ideally, the model will perform well on both with similar behavior. So your trend will remain same, training and testing. It is gradually decreasing, logarithmic decrease or whatever.